Welcome back. In this lecture we're going to be doing dilution calculations. So in your textbook it's page 97 to 201, and the objectives for this lecture are pretty straightforward. We're going to be doing the calculations necessary for the dilution of a solution to a predetermined concentration. Now, the reason we need to do these calculations is often when chemicals are sold, especially for chemical laboratories, they're sold in what's called a stock solution. So stock solutions are solutions of very high concentration, and let's get my pointer out here. So these are very concentrated solutions. So before they can be used, they have to be diluted. So the reason they're shipped this way is because then there's less chemical waste and it's less dangerous. You're shipping small volumes. So it's less likely to spill. So small volumes, which really means small containers. So standard solutions are made using precise glassware and electronic balance to weigh the solute being dissolved, and these solutions are prepared through the dilution of a stock solution or by diluting a pure solute. So sometimes your solute will be sold as a solid, and it needs to be put into solution. So the dilution formula is pretty straightforward, and here's the general idea. If you take a concentrated solution, so here we're just going to draw a little beaker, and it's full of water, and if this solution is concentrated, so here's a concentrated solution, and each of those little blue dots represents a molecule. When we dilute it, so this beaker contains a solution, we can find the number of moles if we take the concentration and multiply it by the volume. If we do that, we'd find the number of moles that are in the solution. So we'd find out that there's 7, or 1, 2, 3, 4, 5, 6, 7, 8. There's 8 moles of chemical in this solution. When we dilute it, all we're adding is water. So what we're doing is we're getting a bigger beaker, we're getting more water, but the number of molecules, or the number of moles, is still the same. So there would still only be 8 moles of chemical in this solution. So the number of moles remains unchanged. So if we have the number of moles, and since we're measuring this liquid, we're going to have the volume, we can calculate our new concentration. So basically, both of these beakers have the same number of moles, which means that the concentration and volume in one beaker, in terms of the math, is equal to the concentration times the volume in the other beaker. And so this is how we sit then. So this is our dilution formula. Is as long as we know the concentration and volume in one beaker, either our stock or what we're going to, we can calculate one of the other two variables. And so we'll jump into an example and we'll see how this works. So a couple important things: always make sure you're working in moles per liter, and always make sure that your volume units are the same. So in this question, we see that we have liters and milliliters. We've got to make sure both of those units are the same. Since for most other calculations we use liters, I'm just going to convert the 200 milliliters to 0.2 liters. And so here we have water is added to 200 milliliters of 2.4 mole per liter aqueous ammonia until the final volume is 1 liter. What is the new concentration? So we have the initial concentration, so C1, and that's 2.4 moles per liter. We have the initial volume, 0.200 liters. We also have the final volume, so I'm just going to call it V2. Sometimes it's called VF, either way, whichever you prefer, is 1 liter. And so what we're looking for is our new concentration. So C1 V1 is equal to C2 V2. We're looking for C, I'll put the little subscript there, for C2. So we're going to divide both sides by V2 to isolate our variable. And so what we have on the right side, our volumes cancel, and we get C2 is equal to C1 V1 over V2. We plug in our numbers. 2.4 moles per liter times the volume, 0.200 liters, divided by 1 liter. And so we end up with would be 0.48. Notice our liters cancel, and we get moles per liter. Since we're diluting our solution, it should make sense that our new concentration is lower than our initial concentration. Since we're adding more water, the concentration should go down. Our solution should become more dilute. I'll just circle that just out of habit, and we'll try another one. Okay, so here we have an experiment. A student needs to make 400 mils of 1.00 times 10 to the negative 2 moles per liter hydrochloric acid. The stock solution has a concentration of 1 mole per liter. How much stock solution should be used? So the question is asking for volume. This means find the volume of our stock solution. So we're going to call this V1. I like to call the more concentrated 1 and the less concentrated solution 2, but that's really just out of habit. So we know that our initial concentration, or the concentration of our stock solution, is 1 mole per liter. We want to figure out how much of this solution we need, so that's what we're looking for. Our concentration of our diluted solution is 1.0 times 10 to the negative 2, times 10 to the negative 2 moles per liter. And our volume of our diluted solution is 0.400 liters. Since my concentration, or since I'm working with liters most of the time, and since my concentrations are in liters, I just like to have everything in the same units. I could do the calculation and get an answer in milliliters. It's just not as fun. We'll say that it's not as fun. So C1 V1 is equal to C2 V2. We're looking for V1, so I'm going to divide both sides by C1. On the left side, the concentrations cancel, and V1 is equal to C2 V2 over C1. Plug in your numbers. C2 is 1.00 times 10 to the negative 2 moles per liter. Volume 2, 0.4 liters, and our concentration 1, or the concentration of our initial solution, our stock solution, is 1 mole per liter, and we'll just run that through our calculator and get an answer. So we get 0.004, and our moles per liter cancel, so our answer is going to be liters, which is good because we're looking for our volume. Liters, when we convert that back to milliliters, we move our decimal 3 spots, 1, 2, 3 spots, so that our initial volume is 4.00 milliliters of our stock solution. So that is it for calculating dilution calculations. There are some problems on page 198. Good luck with those, and I'll see you in the next lecture.